Hello, this is PETRIE. Now we have to actually design the assembly fixture that we are going to make. The proposed fixture must compress all 16 detents into the clutch body. But first, before we get into designing, I would like to introduce you to a technique that I first learned in 1963. It's called the systematic design method. In fact, I have found it so powerful and successful that I have used it ever since. It is worth noting that I have used this technique in all of my inventions over the last 52 years and continue to do so. I was so impressed with the technique that when I myself became a university lecturer in engineering design, I taught it to all of my students. Basically, what you do is construct a simple chart similar to the one shown. Down the left-hand column, you write all the functions which are important to this particular design. In our case, there is one overriding function. The fixture must work first time, so haymaking may be restarted. This is so important that I've shown it in bold. Next, fill in all your other desirable functions, such as quick to manufacture, etc. It is important not to evaluate any of your concepts at this stage. Simply just think how it could be possibly achieved. Now you may evaluate your ideas and, in doing so, assign a score to each function of each individual design. Now simply add up the scores for each column. The columns with the highest scores indicate the most promising designs. In our case, it is the quadrant and cone concepts. However, the cone has a lower score in the most important function, that it must work first time. So it follows logically that we can go with the quadrant design. Now all we have to do is calculate the spring force of each detent and design can commence.